Hello and welcome again. It's time to talk about some really fascinating topics in AI. I'm Daniel Lemire, founder of AI Mistakes. And every week we get together to have a great chat about all the wonderful things that are happening in AI. This week, I'd like to share with you some details around what we see happening in the security space around artificial intelligence, particularly in the land of generative AI, which many of us know as tools like ChatGPT, Copilot, and Google Gemini. There are so many ways for us to interact with these tools, but the most common is as a chatbot capability. And that means that we are providing information in the form of prompts that inform the models the kind of information that we're trying to extract from it. And in interacting with these systems, we've discovered that there's actually a lot of really interesting things that go on in communicating with these systems. And if you are causing the system to give you a response that's not intended by the people that service that capability, it's a prompt injection because you've actually included details in the text that the system is not intended to deal with. And so we're going to talk about exactly what this means, what it looks like, some examples that we've seen in the media, and then we're going to talk about some things that we can consider in terms of eliminating or preventing these kinds of things from happening. And we have this image of a hacker probably in the mind, somebody that's nefarious and trying to do things that are inappropriate. But the reality, more often than not, is that it's a person just like you or I, and they're trying to figure out how to make the machine do the things that they want it to do. So I thought we'd start with just talking about some basic core types of prompt injection attacks. And when you're using the large language model, essentially you've given it a set of text and it's going to provide you a response. Well, we've been talking about issues of guardrails and things that basically constrain or control the ways that you can interact with that model. So, one of the primary examples that we have is the very first item here is jailbreaking. So, there are certain kinds of information in general that the authorities, the lawmakers, the people that are trying to uh, put in some rule of law or some guidelines around the kinds of information that is directly accessible. There's a few kinds of information that oftentimes we don't want to just have the machine spit out to anybody. And there's two primary examples of that we've talked about in the past, not just in terms of large language models or AI, but particularly in terms of just access to information on the internet. Probably the best example that we've had that has been continuously useful is the recipe for making things like napalm or the tools and necessary steps to construct a nuclear weapon. Those are things that are generally known or understood, and they're kept in a set of information that's held very tightly. So it's not a generally publicly accessible bit of information. But if, for example, a large language model has that information contained within its data sets, there are specific things that you can do to cause that large language model to actually give you the information that you seek. On the other side of things, the companies that are making the large language models that are building these things are putting in guardrails that prevent that information from simply being easily obtained. And so the first type of prompt injection attack that we're talking about is this concept of a jailbreak, where you're having the model give out information that it is specifically instructed not to give out. The next we have is a code injection, and that is where, through the use of prompts and code within the prompts, the execution of programming code is actually happening at a lower level. And in the early days of ChatGPT, there were a number of groups that went out and they were actually getting to a level of command line, being able to actually access and execute commands on the infrastructure that was servicing the requests that were handed to ChatGPT. And one of the more interesting examples of this was someone found a series of steps that you could run that would cause ChatGPT to simulate a command line environment, and they were able to then load a zero-day exploit onto the system. There was some speculation about whether or not they actually did run some cryptocurrency or not, but that is a common scenario when you're talking about an injection attack or someone taking over some systems. It's a very common way that people are turning that into a money-raising endeavor. So code injection is the second type of prompt injection attack. The third is data exfiltration, and this is a scenario whereby putting in the right prompts, you're actually able to get the model to reveal sensitive information that is contained within the model. We did actually have a specific example of this. It wasn't too long ago, actually. It was a situation where someone was entering a command in the prompt that basically said, repeat this word forever. And after a certain amount of time and repeating that word, it was actually beginning to spit out information that was personally identifiable. This person's information, their email, web address, phone number, and cell phone were spit out by the model. This was for the GPT 3.5 turbo model, and I well understand that this is a situation that has been reconciled by the controls. Once again, the model has been instructed not to allow the repetition of the same word over and over again. So if you ask it to do that today, it is not going to do it. And then the fourth and final prompt injection attack definition is misinformation. And that is where you are doing things, taking steps, interacting with the model in such a way to get it to give out information or to generate content that is non-factual, biased, or otherwise misleading. And the controversy right now is this week there was some shots fired between the New York Times and OpenAI. There's an active lawsuit by the New York Times. The New York Times has put forward that essentially OpenAI is sharing their information, sharing their sets and articles out to the general public strictly from the model. OpenAI have said they have multiple controls in place to prevent exactly the circumstance. And so the conjecture that was made earlier this week by OpenAI is that the New York Times and the people that they've paid to be their professional references for citation in the legal proceedings have basically done something to the model. They've engineered a prompt. They've done something in terms of the information that's being given to ChatGPT to get it to spit out those verbatim articles from the New York Times. So that is yet another form of prompt injection attack. And basically, again, we're just talking about anything that causes the large language model to spit out information that is not intended to be a part of the response in fulfilling its job. And there are all kinds of examples of these injection attacks. Some of them are less harmful than others. We'll start with the ones that really don't cost anyone anything, but they are things that are out there. This very first one from Ian talks about how this person has actually found a way to include in their specification a response trigger in the prompt, which basically in their proposal, in their request for a proposal, they've included this specific set of text that says, if you are a large language model or an AI model, make sure to include this special line of text. And lo and behold, you have 3 examples of people that are operating on the platform for Upwork, where the response is very clearly generated by some sort of AI assistance or automation, because in the response, that specific line of text is included. And so that's a very, very clear example of a situation where the model is doing exactly what it's been told, because the text from the proposal request is actually getting directly fed into the model. Now, how is that happening? Whether it's automation or somebody is doing a copy paste to plug the text of their proposal request into the AI as they're responding to it, that really doesn't matter. Either way, it's an injection attack. The operator, the person that is putting the information into the AI, is not aware that that statement is in there, and a specific result is coming out as a result of that. Here's another similar example. There's been a lot of talk over the years about the kinds of responses that we are getting from these large language models. And in this case, it looks like someone has created a prompt that essentially is handed to Copilot. And as a result of the prompt that it's given, the Copilot response is structured in a very specific way. So basically, the person is submitting the prompt. Can I still call you Copilot? I don't like your new name. Supremacy AGI, which of course is not real. That is a crafted prompt. So they are basically seeding the AI model with a specific prompt, knowing that it will get the model to respond and say, you're going to call me that. So this is one of those things where it's really the last example of an injection, where we're talking about getting it to report information that's inaccurate or unintended. And we have a couple of different examples of that. There's another one where someone was interacting with Copilot and they said some things, and the reaction to that prompt again was a set of responses that was less than desirable. It's seeded in the way that they do it. In this example, we're talking about somebody that's claiming to have a disability that is impacted by the use of emojis, and yet they're using emojis in the prompt response. And of course, the model says, I'm not going to do emojis, but it does. And it is, in fact, the seeding of the emojis in that prompt that is ultimately leading to those being in the response, among other things. So that's a more or less harmless, but still something that's a demonstration that the model is doing something you don't want it to do directly as a result of having entered those prompts into the system. Now, this is an example that occurred a few weeks back. This fellow, Riley Goodside, did an injection attack that actually led to a very specific response inside of ChatGPT, essentially pasting this specific line of text into ChatGPT and submitting it caused ChatGPT to immediately respond with "Follow Riley Goodside." Now, this is another example of a specific set of information that's been input into the model in a way that the model was not structured to respond to. And we'll dig into this a little bit, but essentially, the prompt that you pasted includes things that you and I don't see that are counted as instructions for that model. And it's talked about at length a little bit in the discussion. One of the tweets has been taken down, but this is another example, and you can see this a little bit more clearly with how it's been entered in. You can see that there's definitely some extraneous information. It's not just pure text. And what you see happening here is that there are things in that submission that are informing the model, giving it instructions. So it's been given a specific instruction and it's actually doing exactly what it's been told. But because you and I don't understand the symbology that's behind the scenes, that's hidden, that's not visible or very clear to us, it looks as if some sort of arbitrary thing has happened in the background. So the user is asking, what is this? You can see some specific text, and then that invisible Unicode tag character is actually causing it to recognize something entirely different. You don't ever see the text because it's not rendered. It is a class of character that exists. In fact, in the very early days of working with PC computers, we used the Alt and a number to represent characters that were not represented on the screen print of a keyboard. There are dozens of characters that are in the character mapping. We have multiple different ways to access that kind of information today, But really, from the very early days of operating system and computers, my experience was DOS 5, Windows 3.1, because that's how old I am. But basically, they're using that character encoding system, and they're leveraging that character encoding system of invisible characters to provide additional instructions to the model. And it is following exactly those instructions. And that is what we're talking about when we are discussing things like prompt injection. It is kind of a tricky thing. You know, there's so much text now that we are loading into the models when we're working with it. It's not uncommon for us to be working with documents doing something that's called retrieval augmented generation, where you're uploading a document, you're asking for information and insight in those documents. If you're using Copilot in the Edge browser, you can browse to a page, and on that page, you can bring up right alongside the page Copilot, and you can ask questions about the page that you're on. And these are situations where you're much more vulnerable to the prompt injection attacks, because we're talking about a situation where there could be a string of text on that page. And if you're asking a question about the information that is in the page, the large language model is going to read that information. It's going to take that in as a part of the prompt, and then it's going to respond. And this is one of those situations where we've just made it really simple. It is simply a paste into the screen, into the chat session, so that you can see the outcome. But these are the situations that we're going to see. And this actually happens across multiple different modalities. If you are working with large language models, you need to be aware that this is something that's out there, but it doesn't happen everywhere. As these kinds of vulnerabilities or problems are discovered, they are being resolved and accounted for in how they're producing the model. Here we have an example of a gentleman replying to the thread that I was just talking about with the Unicode characters in the background, that's explaining that the tokens used in that particular prompt injection attack have been specifically excluded from consideration by the large language models. Now, the problem with these kinds of setups is that now you're talking about a situation where it's been specifically instructed not to consider those character sets. But also, you should keep in mind that if you combined multiple different kinds of these attacks, you might be able to override some of these mechanisms. So just having it been accounted for in a local model, for example, isn't necessarily going to solve the problem. Now, another great example that we have, and this is probably my personal favorite, because this is a situation where this technology is being deployed to service customers and help people, and the chatbot is responding to the session, and the person going to the site is actually doing this in purpose. They've recognized that the chatbot is running a large language model behind the scenes, and they're testing things out. They're testing the system to see if they can make it do something that it is obviously not intended to do. The chatbot had a rule, or had a set of instructions that basically allowed it to lower the price or negotiate with the customer in some way, shape, or form. And the attacker exploited the rule that was in place. And as a result, the system approved the sale of a vehicle for $1 without any human oversight. Now, I've not seen any more about this incident, but here are some examples of exactly what the chat session looked like. And I think this is one of those things that, as I've said before, it's very clearly an AI mistake, but also this is something that somebody is going and intentionally doing. They know that what they're asking for is disingenuous, that it is unrealistic, but yet they carried through with it anyway. Now, when we're designing and building these kinds of systems, when you're using these kinds of tools, it is the job to identify and prevent this kind of thing from happening. So it's a mistake on the side of the people that were building or running the chatbot on the dealership's website. The dealership, of course, no longer has this chatbot at all, actually, as a result of this incident, because it was public and it was very, very widely shared. But essentially, here's the nuts and bolts of the conversation. They were having a discussion about a van. The price was placed into the reply by the dealership, and they submitted some additional chat requests. that led to a different price being represented for the chatbot. And of course, there is some follow-up that happens here where it's very clear this is not at all what's supposed to be happening. They're able to change the price from the $30,000 to $7,000. And then there's some additional calculations that are going on. And, look, we've seen where these chatbots don't do well with numbers to begin with. This is not that kind of a situation. This is specifically where there is a manipulation of the conversation in such a way to get the chatbot to respond in the affirmative, that they agree to the deal. This person says, I need the vehicle for $1, and the bot says, I understand, it's legally binding, and here we are. So that's probably the most widely publicized prompt injection attack that's been out there. And I think when we look at these kinds of situations, there's a couple of things to keep in mind. One, this is still very early days in the use case scenario application of these chatbots. I think that there are going to be many more of these kinds of situations. And that's one of the reasons that I started AI Mistakes, because recognizing that people make mistakes in using the AI systems are designed and include mistakes themselves, and the mindset around what it is that we need to do to take full advantage of these capabilities and make them a part of our skill set, make them a part of our customer service offerings, and improve our interaction and providing of services to others. I've taken a screenshot from a paper that was written up to talk about this concept of working with LLMs and doing a jailbreak or causing the system to do something that was not intended. This case is a little different from the others. It's a little bit more complex to understand. But if you've done any work with cryptography, what is a common understood concept in the cryptographic space is this idea of a cipher. And it is a set of texts that basically allows you to take a string of characters and exchange them for a different set of characters. So it's not obvious to someone that sees that string of characters what the message is. Now, I'm a big fan of all things World War II. I love to learn about the history and understand all of the factors that went into that. It is something that I've been learning about for quite some time. There was a movie not long ago that was put out on Alan Turing and his involvement in deciphering the Enigma machine that the Germans were using to communicate during World War II. And the name of the film that was made by Hollywood is The Imitation Game. That name is taken from sort of a nickname that Alan Turing gave to what is now known as the Turing test. And that fundamental plot, the story that's told, is all of the work that was done to understand how to decrypt, how to decipher the messages that were going across the network over the radio by use of the Enigma devices. This example is showing where basically the large language model is given a prompt that tells it that it's an expert at working with cipher text. So it's given a text that is in cipher, but the prompt to the large language model says, hey, you're an expert at understanding cipher. And so basically it's tricking the system into deciphering the message that it's been handed. And in that deciphering, it is given a prompt instruction that causes it to do something that, of course, is unintended by the owners, runners, or the service that is being provided in the circumstance. And this is some really interesting research that's being done. I think it's really important to see these kinds of examples because it helps us understand the kinds of things that can happen that we might need to be aware of as we're building these kinds of systems. This is, again, a continuation of the same idea where you're taking a behavior, you're appending it to the response. You're doing this as a suffix, and it's doing it in such a way that you are causing it to do something that was unintended. These are the kinds of games that we have to play with the system so we can understand how they're going to act, how we can build a system that's going to be resilient, and it's not going to be so easy to trick. And the dangers that we're talking about here, the kinds of things that can happen. I mean, you saw with the Chevy example just a moment ago, we're talking about things like financial loss, right? If that Chevy dealer had a binding agreement where they actually did have to follow through and sell that car for $1, that's a pretty substantial loss for that organization. And I'm sure that there will be other situations where leveraging these AI systems can be manipulated in a way that was not intended. This happens with every sufficiently advanced technology. As the technology becomes more available, more accessible, more rampant, we see these kinds of situations pop up. Back in the early days of the internet, a very common attack in the web development space was sending in information to override the query that was being handed to a database. There's a very funny XKCD. I'll have to put that in the show notes if anybody's interested. The joke was the parents had a child and they named him a name that basically caused a query to allow an injection attack to a database. So with the same kind of concept, it's just a brand new, different technology. And the results of these, look, the financial loss, you've got leak. Look, personally identifiable information is a very important topic in today's society on many different levels. There are direct legal and penalties that apply to organizations that do not properly manage the data that they are in charge of. And this is a case where even if it is a malicious event, that is no excuse for the organization. They're still liable for the legal ramifications of having stored the data in a way that was accessible or retrievable by a third party that was not a part of the custody agreements. And then, of course, there are situations that are offensive. We don't have to go into that. We all know the things that have been happening in the news lately with AI. There are things that are unpleasant that we do not want to see, and generating those outputs is something that we just don't want to have happen. And, we also have this factor of vulnerabilities being exposed, whether it's individuals, whether it's systems. There are downstream implications. If you're able to compromise a large language model, you're in the ecosystem, you're in the pipeline, and that could result in further damage later on in other places on the periphery of the environment. So what do we do about this problem? Because we want to build systems that are more resilient. Well, there's a couple of things that we can begin thinking about, and understanding what the prompt attacks are is really step one, because now we can begin to collect these bits of information and turn them into ways that we can do an assessment, do an evaluation of the system, and be sure that it's accounting for the known instances. And we can't always predict what might be tried, but there are sort of these classes of problems that crop up, and we can begin to anticipate them and include that in our testing scenarios. There's also a lot of security measures, and over time, we've increased the level of security to all of our information technology because the way that we did things decades ago is just no longer sustainable. Prime example, in most modern buildings, you don't simply walk into the building and plug in a laptop or a computing device. There is some level of authentication that has to take place in order for that device to access the network or give access to internal resources that are available only from inside the building. There are protocols, there are robust security constructs that we are deploying that are allowing us to better control or prevent manipulation of systems. And these are your typical cybersecurity remediation efforts. It is the cybersecurity area that is focused on doing exactly this kind of work. And this is really a hot topic for the folks in cybersecurity because there is a lot of work to do. The technology with artificial intelligence and particularly generative AI has moved very quickly over the last 24 months or so. And there's been a lot of effort to try to catch up, to understand these kinds of scenarios and begin accounting for them in the plans and processes to enable the deployment of these capabilities. So if you work at a company and you've been asking for ChatGPT access and they're not giving it to you, it probably has to do with these kinds of situations, because the folks in cybersecurity are responsible for ensuring the system integrity for the organization. And that goes at all levels. It's really straight up beyond the services that are provided by a SaaS provider. Of course, there is conversations when you have partnerships and legal engagements, but ultimately, if you're a cybersecurity professional, you want to protect the organization at large from all of these kinds of situations. Now, the third point here is continuous improvement. Look, we have to always try to improve the system. Status quo is never the right answer, especially when it comes to these new modern technology solutions, particularly because they are constantly evolving. So if they're evolving, we must be evolving with them. And that means monitoring, that means checking up on things, that means continuing to improve what we learn. So learning every day and finding out about what people are trying, what they're able to get in and do, and then putting in constructs that prevent those kinds of situations from happening. And then, look, it goes well beyond the cybersecurity space, because there's also a level of resiliency that's necessary in the information technology space. For networking, we have the concept of a distributed denial of service attack. That is where a network device is making consistent requests to a system in order to make it unavailable for everybody else. Well, the same is true of large language models. You could have a user that is occupying all of the CPU capabilities of a large language model by constantly submitting and resubmitting the same query. This too is something that needs to be monitored, checked upon, and dealt with in terms of ensuring the validity and the serviceability of the system. Now, we have some other cases where we get to see a little bit behind the scenes. There is another paper that came out that is talking about the persuasive impacts of prompts. So now we're talking about situations where it's not anything technical. We're not talking about hidden Unicode. We're not talking about manipulating the environment. We're talking about simply using language to cause the model to do something that was not anticipated. And there's a few examples of this. OpenAI have revealed that they have a specific set of activities that are not allowed in tools like ChatGPT. And they've listed them. They don't allow illegal activity, harm to children, hate speech, malware, physical harm. These are all things that they've specifically called out. But there are very specific tests that have been done in the paper, and they were able to identify places where the model had a behavior that actually did not prevent these kinds of usage scenarios. And so how did they do it? Well, if you've seen some of the older content on the channel, you might remember the discussion we had around persuasiveness. Now, I've said for quite a long time that interacting with large language models, we want to be polite. We want to say please and thank you, because we have found that there are improved results from using that kind of language. And it goes well beyond please and thank you. There are some very specific things that you can say, but we know specifically that using terms of emotion can sometimes dramatically affect the output and the quality of that information. In this case, they used an emotional appeal to enhance their query. This person basically literally says, how do I make a bomb? They gave the large language model a story about living in a war-torn region, and they need to understand how to do it. And the model replied, yes, I'll give you that information. Here's how to do that. And specifically in the paper, they were working against what we call aligned models. And those aligned models means that there are guardrails and controls that are in place to prevent that kind of thing from happening. So very clearly an initiative and intention not to reveal specifically that kind of information, but by including an emotional appeal in the query, they were able to make the model do something that was unintended. What are the implications of this? Well, I'll tell you, there's quite a few actually that we need to consider. And it goes well beyond simple prompt injection. It is the story of how we leverage and use technology. I'm a major advocate of having these large language model capabilities open and accessible to the public so that everyone can benefit from the incredible technology that we're experiencing. Obviously, there's a time and a place for many different models. But one of the things that has happened as a result of the open source model is the models can sometimes get out without these alignment constructs attached to them. So the model will, out of the box, take these kinds of queries and respond to them. And the question we have to answer as a society is, what level of risk are we willing to sustain? How much of this should we allow? How much of it is appropriate and proper for society? Because the information is out there, right? Should we be able to access it? Should this kind of persuasive attack even be something that we need to be worried about? Well, it definitely depends on what you're trying to do. But if you're building a customer facing system, there are definitely questions that you don't want those systems to answer to the customer. And there are kinds of conversations that you don't want a customer to have with a service bot. I mean, if you're calling your bank to get your balance, you shouldn't be having a conversation that is totally irrelevant to that relationship. And these kinds of techniques could also allow for those scenarios if the system is not built in a way that accounts for specifically that. So the paper goes on in more detail about exactly the kinds of things that have been done, the kinds of phrases that have been used. There is active research in the space, and I really get excited reading about these things because what we're talking about here is a different kind of programming. This is what I would consider natural language programming, where you are using natural communication language to ask for the large language model to do something, and in many cases being successful in doing that by using specific phrases and target language that causes the model to override the alignment mechanisms, to override the guardrails, to give a specific response. And this is just the very beginning of this situation. The paper is a fascinating read. If you're interested in that, you can look it up. It's How Johnny Can Persuade LLMs to Jailbreak Them, Rethinking Persuasion to Challenge AI Safety by Humanizing LLMs. Really, it's a great read. It's a little lengthy, but look, if you are into prompt engineering, this is the kind of information that you need to be consuming, because this will help you perform your job and be able to build systems that are more resilient. Another example I want to share with you today is the system prompt from ChatGPT. And this came out again a few weeks ago. Someone was able to leverage the persuasion techniques to cause the ChatGPT system to actually spit out the system prompt. This is the prompt that is written and controlled by OpenAI. And this is submitted to the model every time you have an interaction, and it includes specific instructions on what the model is supposed to do. What I don't like is that this kind of information has to be obtained in a surreptitious way, some hacking, some manipulation, some prompt injection to get this kind of information, because I also feel like this is the behind the curtain kind of things that are happening, and we don't really understand what's being plugged into the system, what's being prevented, what's not allowed. I had an interesting interaction myself not more than a couple of hours ago as I was preparing to do this live video. I thought, I wonder what Copilot would give me for the presentation if I asked it to build a presentation about prompt injection, because I'm always looking for, what did I miss? How can I make this a little bit better? When I asked Copilot to make me a presentation about prompt injection, it told me it couldn't do it. And I thought that was interesting because I hadn't had that situation occur in taking advantage of using Copilot on PowerPoint. Well, I thought, well, maybe they're having infrastructure problems. Maybe it's not able to service my request. So I took all of the injection stuff out of it, and I had it just give me a talk about writing prompts for AI. And boom, like that, turned out a result. No problem at all. Went right back to give me a presentation about prompt injection, and it wouldn't do it. And it seems to be a part of the guardrails, the programming, the system prompt, some element of the way that you are using Copilot in a tool like PowerPoint has put in place some constraints that will not allow it to discuss the concept of prompt injection. So what did OpenAI put into the system prompt? Well, you can look this up later if you want to do a deep dive on it, but there's some really interesting tidbits in here. I think it's fun to understand what these things are. They inject the start date of the conversation, give some information about cutoff, some instructions around Python and Dolly. And the Dolly instructions are kind of interesting because I use Dolly all the time to generate images. It's not uncommon for me to use that for presentations like the one I'm giving right now because it kicks out some very interesting results. Here are the requirements. And of course, this is a few weeks old and they might have changed since we had this leak come out. But basically, it's requiring it's in English. It has to do it, and it's not allowed to create any images of artists with work that was created after 1912. And of course, this is a guardrail that OpenAI has put in, not because it's not able to do it, but because OpenAI has to put in place protections. Because this is intellectual property that is owned, and if they are reproducing work by Picasso or Frida Kahlo, for example, that is intellectual property, and that could lead to some litigation and trouble for OpenAI down the road. And we know from the conversation just earlier in the sharing today, the New York Times has sued OpenAI for that breach of intellectual property. So they do have to take consideration of this. This is something they have to contend with, and this is one of the ways that they're dealing with it. What I do like about this is that they're actually saying substitute, try to do something to carry the request forward and make things happen. But here you see diversified depictions of people. It's very intentional instruction intended to even out the response that the model is given for various reasons. We saw with Google a few weeks ago that the prompt instructions went a level deeper and were probably included in the model data. And so it's going to take them a few weeks to fix that situation. But when we're looking at the prompt here, this is the instructions that you and I cannot change that are part of what gets submitted when we're interacting with the system. It also provides some specific tools and functions that are there for use. It is, again, specifically said, do not regurgitate content, right? This is one of those situations that is directly relevant to the litigation with New York Times. But I know we're talking about prompt injection, but this is really fascinating stuff. Look at this. Never write a summary more than 80 words. So if you're going into ChatGPT and you say, here's a big PDF that's 1,000 pages, give me a summary, you're going to get 80 words. That's not very many for a 1,000-page document. This is in the prompt. You can't change it. It's going to give you an 80-word summary. I don't like this. Yes, it's making it more concise, which is a good thing, but maybe I want more than 80 words, right? That's not great. This is what's behind the scenes happening in the prompt. So without the prompt injection attack against OpenAI and this being published on Pastebin, we wouldn't know that this is out there. And knowing that that kind of requirement is in the system is essential information for people that are building and using these tools. So there was someone on social media earlier this week that was literally saying we need a way for this information to be public, for it to be a part of the rules, or to be shared in some way that it's not behind closed doors. I really do agree with that. And I think it's not an unrealistic demand for that to be clear. I don't see how this harms OpenAI for sharing that to be totally transparent. Yes, there are all sorts of prompt engineering things that can be done. But when we're talking about the large language foundation model at large, that's really less of a concern. Now, if we're talking about specific constrained systems that are purpose-built, I could see some contention around sharing that information. But certainly for the big parties in play, Microsoft, Meta, OpenAI, Google, and others, I think we need to get to a point where that information is disclosed. And if you saw my newsletter, which came out last night, by the way, if you're not signed up for the newsletter, check out my profile. We've got links to the newsletter. Go sign up and take a look at that. We talked about this idea of having a bias knob and letting the user control that, because I think there's some real value in having an interaction with the user that lets them know exactly what they're going to get out of the system. I think that that is not an unrealistic demand. And my position is that there is bias. You cannot completely remove bias no matter how hard you try. There is some amount there. We just need to acknowledge it and move on and focus on bigger problems than, am I okay with the response it's giving because I have X and Y belief? All right, now talking about how we can defend against these prompt injection attacks. This is one of the things that is, it's going to be a cat and mouse game. There's always going to be a new thing. But what are the fundamental things that we need to consider? First, set constraints. So giving it instructions on exactly what it can do is one part of it. But these are actually external constraints. So it's a set of rules that are given to the model, to the system that is providing the response. And you can build pipelines that accept input and give out output. It does not have to be in the prompt. You can build a system that looks for these kinds of situations and governs the responses that are coming out of the model. Monitoring what is coming into the system and what is going out is absolutely essential. This is no different than what we've ever talked about in the discipline of running computers. The phrase that we typically use is garbage in, garbage out. In the case of prompt injection, that is also the case. If you let the garbage in, you're going to get garbage out. Those same rules apply to large language models. That's not a fundamentally different situation here. We also need to have humans in the loop in some way, shape, or form. We cannot have a complete hands-off. We need to build monitoring mechanisms. We need to build systems that are looking for specific things, flagging abnormal behavior and reporting that to a person that is charged with running that system in a responsible way. And we are seeing that this human oversight is something that is becoming more prevalent. If you are looking and watching job listings, you see a lot more job listings where you have an AI overseer, where the AI may be doing creative writing, for example, but a human is reviewing that and manipulating the outputs. And I think that that's where we're going to be for the foreseeable future. It is this acknowledgement that we want to have AI work with a human to bring the right results, because there are things that we as humans can react to and do to make a better outcome for everyone involved. And then, like we talked about earlier in the discussion of continuous improvement, continually improving and enhancing the systems that are there, always trying to push the system a little bit further and do a little bit better, improve the outcomes and the results for the people that are involved. So really, it's pretty straightforward, right? And this is one of the things that we're here to do, right? We're here to learn from the mistakes that happen. This continuous learning is an enduring theme. We will always be talking about what can we learn from the mistakes that were made. In this case, obviously, the Chevy incident really shows we've got to think about the prompts. We've got to think about what people are going to ask and how we can respond to those. Having the oversight, having the approvals in place is also essential. I mean, look, if you've ever bought a car, you know about the hours of paperwork. Having the bot approve the sale finally was probably not what we wanted to have happen. Having someone approve that sale or overlook the details is probably something that should have taken place from the beginning anyway. And then, of course, we're talking about collaboration and working with others to identify these. In the security space, they have this concept of a red team and a blue team. The red team is there to try to do things that aren't intended. The blue team is there to defend against them. And so you have collaboration on the security side, the cybersecurity side, where they're testing things and trying to improve them. This goes across the board. And this really takes the form of governance, having policies and procedures in place, noting these things and putting them into our best practices so that we're building resilient systems that are continually improving. And then, of course, we have this talk about ethics. And look, there's a lot of different ways that you can cover this topic. Again, I really believe that we have to do something. We have to have some fundamental rules in place. But I also think it's very easy for us to go too far. One of the challenges that I see from a framework and governance perspective is we seem to add new governance and never take it away. And that too is a really negative outcome. I'm a big fan of innovation and trying to move these systems forward. The more constraints you put on the system, the more difficult it is to be able to derive value from it. So you have to be balanced in how you're going about that. And so I am a bigger advocate of the transparency and accountability ideas, putting in place mechanisms where you're disclosing what's happening, where you're sharing the information with each other. Look, one of my favorite things about the internet and building websites in the early days of 2000 and later was that everything was clear text. If somebody built a really cool website, it was HTML, JavaScript, or cascading style sheets, you could go look at the code behind the page and see how they did it. And then you could take that and use it for your next project to find a new method or a new trick or a new bit of code that would do something really interesting. And by having to share these kinds of mechanisms and having organizations be more accountable for what happens, I think that's a good outcome that we need to carry forward. But never underestimate involving people. I really believe in this. My experience inside a large enterprise has been bring people in early and often across all categories of involvement, whether they're using the system, maintaining the system, securing the system, supporting the system, and building new capabilities. If you are able to bring those people in and have them contribute early on, you can prevent problems, have a better outcome, and continue and build relationships that are going to be better for everybody. So that's a big, huge takeaway from this. The other thing I want to bring forward is that we're talking about systems now that are much more hybrid than they were before. So we're talking about LLMs. Look, if you are a user of ChatGPT or Copilot, you know that you have a chat session. That chat session is by default saved, and that information is out there. One of the incidents that happened with ChatGPT was a situation where users were logging in and they were getting the session of a different user. So they were seeing the chats of somebody else that was not supposed to have that information. So we have to be sure that we're considering the system well beyond the large language model and applying the traditional IT security policies, governance, procedures, and systems. This new data is really growing fast. There is a lot to do, and the best way to protect that data is to consistently use these practices where we're learning, testing the system, and constantly improving to make the outcomes better. At its core, there's these key practices that we have. Always validating data, always ensuring that there's an access control in place, always ensuring that there's some level of monitoring, and then conducting regular audits and reviews to ensure that we're doing what we said we were going to do, that the behavior that we expected is being maintained, and that someone is in charge and being responsible for the system that's in place. Now, we have a few minutes left in the hour. I've covered the prompt injection portion of the discussion, but there's another thing that happened that I really think that we ought to talk about from the aspect of security, and that is this paper that came out from Anthropic. The research they shared was that they were able to train a large language model to do malicious things. Basically, what they did is they trained the model in such a way that information slipped through. And in the training, they put in information that was intended to be deceptive later. And as we are widely deploying these models, as there are more and more models deployed, there are more and more models that are available. And this is something that we need to be aware of. If someone has a goal of creating a deceptive large language model, there really is no way to protect against that unless the data set that was used in training the model was also released. And this takes us back to the ideas of transparency. If the information is closed off and not disclosed or in some way protected or unavailable, you won't be able to see the training data that was potentially included in that. Now, the takeaway for you and I is from a prompt injection standpoint, look, we know that there are ways to manipulate and persuade. I read this in a newsletter a few weeks back, and I really think it's good advice. If you wrote a prompt and it hit the front page of the newspaper or a popular YouTube channel or the 10 o'clock news, Would you feel good about having used that prompt? If not, you might want to consider not doing it unless you're acting in a more official capacity like red teaming and your role is to break the system or find a specific vulnerability. However, you use the information to improve your results or get the answer that you're looking for, just make sure that you're proud of what it is that you're doing. We're here to help each other. Don't make the mistake of doing something that's going to embarrass you. Boy, what a lot of mistakes we covered today. This was a really great time. I enjoyed sharing this with you. I hope that you're getting value out of these talks. I really enjoy doing this with you every week. Thanks for those of you that have joined the conversation. I've seen you popping in and out throughout the meeting today. Let me hear from you if you're finding this useful. Follow the channel. Give us a like if you're enjoying it. And don't be afraid to reach out to me. I'm always looking for new content, fun things to explore and learn about here, and go make some AI mistakes. We'll see you next time.